Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Good. So, last session we had spent a little bit of time with this thing here. I wonder if we should rename this one here, class deck context name. No, we only ever parsing context name. Yeah, context name. Yeah, context type. No, I think the function name is okay. Okay. Get context function info. Yeah. Okay. Context. Yeah, I think as long as everything's correct, then I think this is good enough. Okay, let's see once more if any of these breakpoints hit. Then remove them. There's anonymous namespace, okay. That's it. Oh, looks like some of these never hit. This one never hits, which is reasonable. And this one also never hits. Is templated. Because we haven't implemented it yet, right? No, huh? If not context. And let me see. Okay. All right. Then, so this is never called. What condition did we have here? Enum context is not 0. Huh. So this one never hits. Interesting. Huh. Context. Interesting. Good. Then this is done. Actually, let's look over the symbols we have so far. Watch this. Okay, so we have a bunch of functions. All right. Good. Fixed section. So we have 3 enums. 2,133 classes. Okay. So in process symbols, we have not yet implemented these 2, right? We also said that we want to have I already forgot what we talked about here yesterday. I think we wanted to change something. I should have put some notes. Right, it was about variable arguments and function arguments. Right, so currently it does, let me see, right. Context template types. Data types from context template argument lists. Yeah, maybe it shouldn't be here, but it should be in the class. So we remove this. And the same in function. So that will have a parameter template types and function template types. And then here we remove this. And then we create a class std string, put it here. Template types. Yeah, let's say class template types, data types from class template argument lists. Okay. So this would mean that we now get 2 reds more here. Yeah, so this means we no longer do this, and we no longer do that. Instead, we create a copy of this, and we do class type, classes, and class type, and then class template types type there, and true. Good. And then we take the context name, context. We remove this one, and we remove this, and then we go to class. Find or create class, and then context name, the context name, classes, class index, class template types equals get context type. No. Get. What is the function name? Oh boy. Here, make templates. There we go. Make template type list, and we give context name. Huh? Takes a string. Why does it take a string? Types. Templated name. Yeah. How about we change this into a string view? Should be possible. String view, templated name is templated, takes also string view. And here we need to say for size ti equals 0, I smaller than size. Count plus I, and then here we say this. It's C plus C. Data plus I. Can we still use the C here? Data. Does it have an end function? And iterator and maybe we should have for see. Let me see. I'm trying to figure out how to write this with a mix of what it was, and can we say C is not equal templated dot end. No. That doesn't work. We can say C is not equal. How would we say end is this plus size, while C is smaller than end, plus plus C. Why is this not working? Huh? Oh. There we go. I think this will work. Yeah. Yeah. So we have context name here. Context name. Why is it complaining? Templated name. Right, templated name. Templated names. Yeah, I think this works. Let's put a breakpoint here. That looks correct. How about we make this a bit nicer? We take this one out. Oops. And we take this one out. And that way, it's probably a bit easier to the eyes. That way, and then that way. Okay, how about we do the same on the other function, this one here. So we have this, and function parameters, templated name. Okay. This std string view. Good. This should work. All right. Then process symbols. Good. So we now have the context. The template names from the class are now inside the class. Yeah, I think that's better. Yeah, and so the idea was that we built enums and classes and namespaces from class arguments. Right, there was the idea, right? So here we say class. Let's create a copy. We comment this one out. I like to comment out things because sometimes I go back and then I say, oh, maybe it made sense to keep that thing we had previous. Only delete when it's confirmed that it's good to delete. Okay. Okay, let's take a copy of this one here, and then we comment out this one. And then here we say class arguments and class arguments. There we go. Oops. Good. So here we have classes and by the way, I just realized I made a mistake. We wanted to get rid of variable, not a function. So we comment out this and this. There we go. See? There we go. So we didn't want to comment out this, but we wanted to comment out this. There we go. Beautiful. Class. Okay. Then here we have class count, and class index. Okay, and here also class index. Okay, good. And yeah, how do we implement this now? So we have a class type. We have classes. We have a class index. We have a from class arguments. Okay, so we have type name from class type dot class template types, right? Yeah, type name. Maybe data types. Maybe we should call this name this class template type names. Yeah. Then we go to variable. No, we go to function here. parameter type names, parameter template type names, and function template type names. There we go. All right, and then we have a bunch of red things because the renamer has screwed it up again. I don't know why it's sometimes so wrong. It's strange. Oh, it's okay. We can fix it by hand. No problem. No problem. Okay, so here we call also function and class arguments. There we go. And here we call this and this and this. Anything else? Yes. Is expected class. What is this? Ah, this is what we're working on right now. Okay, so here we have the type name, template type name. Okay, type name. So, and we say, what do we say? Build class or namespace from variable context. Build class or namespace. So let's see. So I think we need to start here. Let's copy this stuff here. And let's remove this. And let's put this. Okay, so type name. It cannot be a namespace, right? We should probably put an assert. Assert not is no namespace, right? Let me say type name. Type name. We can check if it is a class or if it is enum. Constbool. This. Assert is enum. There we go. Is known enum type name. Okay. So if not is class and not is enum. But hold on, it says build enum or class or namespace. Hold on. Huh? Why did we name it like that? Build enum. From variable context. Build class or namespace. Build enum or class. It should be just enum or class. Yeah, I think we should rename it. I think this should be called build enums and classes from function arguments. Build enums and classes from class arguments. Rename. There we go. There we go. I think this is correct. And then here we would say function index and class index. Yeah. And then So if it's not a known class and it's not a known enum, then we go in here and we will get context type. Yeah. Get context type. And we know it is not a namespace. I think yeah, I think we expect enum here, and we never expect this to be. We never expect this to be a namespace, right? Namespace. Like that can't be. It must be 0. I think so, yeah. I think this is correct, maybe. Yeah. Okay, and then so do we ever want to build an enum actually? Yeah. Yeah. So if not expected namespace. Yeah. It should be an if it is, what takes precedence? I would say if it is class, then we take that. Otherwise, we take it's an enum. Yeah, find or create class by name, type name, find or create enum by name. Yeah. So we say variable, 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 class type. It's not parents. It has no relationship. Well, not yet. Class index. Yeah, I don't know. Maybe we don't build a relationship for now. Just have it like so. Yeah. Enum. Oh, oops. Find out create enum by name. Okay, there we go. Okay, now looking at this, get class name, get context. Maybe we should rename this function to get candidate type. Get candidate type. Yeah, maybe. Candidates type. And then what we should have though is const index t class index m classes class index dot candidate type flags equals candidate type. Yeah. Const index t enum index enum index. There we go. Okay. Candidate type. Yeah. Yeah. Okay, I think this could be good. Let's put a breakpoint here. Let's let's remove this one here. How about we move this function up here. How about we make this simpler? I count. Look, so much less text now. Count. There we go. Count. I. Some bit slimmer. Yeah. Good. Then let's see if that breaks. It should break because we go through all classes. Yeah. So there are template types, type name. So is known. So we have an assert. It's not a known. Science type. This should be an enum. I think this should be an enum. Science type. Yeah. It's very likely an enum. Okay, so it's not a class and it's not an enum. So this symbol is unknown, the science type. It is a candidate type is a class or enum. And so it classifies it as a class here. Okay, let's see the next one. STD allocator is a class. It's known already. Look at that. Okay. Interesting. And now it goes to science type again because now it should know it. It's class true. Yeah. Okay, let's see the next one. Name key type. It should also be an enum. Is class false? Is enum false? Enum class. Maybe we should give the enum priority. I wonder. Yeah. We could. Do we ever get a breakpoint in here? That's a big question. STD pair, that's also a class. Yeah. It's a type def though. It's a type def. Yeah. Is class false? Is enum? Okay, so this one is not known, so it will be created. Yeah. Candidate type is for class. Aha. Name key type is okay, it's already known. Veterancy level. This also looks like an enum type. It's not known here, and it will be classified as class. Yeah. We get a lot of enums here. Yeah. How about we give? Let's see. Let's give priority to enums. So we move the enum up here, and we move the class down here. Yeah. Let's put a breakpoint in here and here, and remove it from here. And then let's see what this gives. Yeah. Let's see. All right, so let's put it into our watch. Type name. So science type looks like an enum. Name key type. You know, type. Let's see, level. Type. I wonder if we should maybe classify a name that ends on type as an enum. Would that make sense? I don't think so. No, it's not explicit enough. Yeah, it's not explicit enough. Okay, this one is a class, yeah. Class, yeah. Float. Oh, well, that's not an enum. Candidate type. Right. We can have these kinds of types. Right. Yeah. Primitive type. We should probably candidate type flags. We should have another type here. Candidate type flags. Primitive. 1, 3. In class primitive. Yeah. And then in this function, we need to check probably after this one here. Yeah, after here we should check if is primitive. Is primitive name is primitive name. Yeah. Return primitive. There we go. Then we need a new function. We can also wrap this one here into a function. Is templated. a comment here. My enum is considered enum. Maybe we should say my type or my enum are considered enums. Then here we say see my type or see my type, my class, or my CS my type, or my struct. Let's say, let's put this here. Comma. Okay, so my type, my enum are considered enums. C my type, S my type, my class, my struct are considered classes. Yeah. And here it's GNU CXX is all lowercase is considered namespace. Let's put this in a separate block. Okay, so we need a function. Oh, my hand still hurts. That's not good. So we need a is primitive static bool is primitive. Cd string view primitive. Yeah. It's primitive. Is anonymous namespace. Okay. So put that here. Static. All right, and then we say we take this one is anonymous namespace, and we pass class name. Return name I think here you can also just pass names. Name. Oof. Name. 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 Good. So name, return name equals that. Good. And primitive, we would say we would have a list, const expr. Well, it's not a const expr function. Who cares? Const std string view. String view. Yeah, string view. And so here we would type all the primitive types. So what do we have? We have char. We have we have all the unsigned types, but maybe we put them afterwards. So char, short, int, long, float, double, long. Let's look up here C++ primitive type. Primitive. I can't type. Primitive fundamental types. Oof. Well, that's a lot. Short. Long int. Long int. Primitive. Yeah. It's primitive. Yeah. Can we just copy paste all this? Oof. That's quite a mess. Okay, so we have char, short int. Is that really a type? Short int. What does that mean? Okay, well, let's put that in. Short int. I wonder if that ever hits. Short int. I've never seen short int used anywhere. Okay, so short unsigned. Int long int. I would expect that these are not. Let's put a breakpoint here. If name equals long int, put a breakpoint here. Same with short int. What else was there? Long int, short int, long int. I don't. I'm not sure if it will be written. Let's put a breakpoint. Maybe it's used. Okay, so we have primitive names. Okay, so why is this not listing float, by the way? There's also a long double. Long double. Long double. Okay, so long, 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 unsigned, equivalent type, short int, long, 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 int, short. Okay, let's remove this one. I think that's all here, no? And then the unsigned variant. Unsigned. Unsigned. I think that should be pretty much it. So we say for primitive, for std string view primitive name, primitive names, if, oof, isn't that a bit expensive? Yeah, well, if name equals primitive name, then return true, otherwise return false. Maybe we should it's probably fast to go through this list. Yeah, it's probably good enough. It's primitive. Let's put a breakpoint here. Primitive. Science type, name key type. Yeah. Let's remove those breakpoints for now or disable them. Yeah. Okay, so here we have a primitive type float. Yeah. Float. And we got an error. Oh boy. Type name float is classified as right. So it can also be a primitive type. Class. Let's change the order here. Enum first. So it can also be a primitive. Primitive. Oof. Looks a bit unholy here, this assert, but okay. Yeah, so it can be a primitive. So we should say else if candidate type and class. And when it's a primitive, we don't do anything yet. it's just a primitive type. Yeah. Man, my hands. What is going on here? Too much hand usage. Okay, float is here. Yeah. Float. There's a lot of floats, yeah. Oh, that's it? 3 floats? Huh? What? No, that was unexpected. Because we don't have so many template types, yeah. I could imagine that this going through the templates could now also add numerics in there, because we will have some numeric template arguments, right? So if we look at classes, okay, there's a bunch of std. Okay, that's fair. Let's look at enums, if we can find it. Enums, we have only 10 enums. Aha, there we go. See, there's a number. Yeah. Pristine bone info. Yeah. Pristine bone info. That could also be. Could be a class. Pristine bone info. Could be a class. Yeah. Height show sub object info. This also looks like a class. Yeah. These three look like enums, but this one looks like a class. This one looks like a class. Yeah. Pristine bone info. Info. Yeah, info. Yeah. It's probably just a struct with members inside. There's no function inside. Nothing. Yeah. Yeah. Okay, but what we should do is none. Candidate type flags. We should have another number. 16. Okay. Get candidate type number is primitive. Is templated. If std is digits. Is digits. So basically, if the first character is a digit, then it's primitive name. Digits. Yeah, so if the name is digit is primitive. Let's have a static bool. Static bool is number. Std string view name. Primitive. Return name dot size larger equal 1 and name 0 is std is digit that thing. Yeah, this number is digits. And we say this number, and I think we can go with name, right? Name, yeah. So if the first character is a number, then it must be a number, because variables and type names, function names, class names, enum names, and so on, they cannot start with a number. They must start with a character. Return number. Let's put a breakpoint here. Yeah. Sorry. All right, so we have a float another float, and we have a number 117UL, and we got an error. Yeah, I think that makes sense. So we need to say or number. Oh boy, what is this formatting? Can we prove that? Const expr. Neat. Well, required. Const expr. Well, expected class. I mean, actually, we don't need this assert. We already assert that it's not a namespace. We expect that. I think that's good enough of a check. Yeah. Yeah. Yeah, I think that's good enough. Okay, let's try again. Yo. It's primitive. Okay, I think that works well. Okay. Then, well, let's yeah, let's it's not too much we get from class template arguments, but I expect we get much more from functions. From function arguments, we should get the most. Yeah. That would be interesting to see. Okay, so we got that. Okay. Then I think we can put this into a function because I expect that this will be the same logic that we use for the function, right? So let's uncomment this one here. Here. So here we have type names. Yeah. Yeah, so my expectation is that build enum a class from argument. Okay, I think we need another function. Void build enum a class from arguments. Yeah. And we just give it a string type name. And we take this guy and I put it here, and then, oops, we forgot one here, put that here, and then we take this and put that here, and we say type name, class, okay, and then here we do function index, class function. So function index type, and then that we call this one here as well. Type, and then we have function template type names. There we go, and then we remove this one. There we go. I think that's it. Let me delete this one here. I think we no longer need that. Then we can also delete that, and that. Function arguments contain class template arguments as well. Okay, this comment is now obsolete. Build types from, yeah. This looks correct. All right, good. Then let's go back to let's put breakpoint here in number and in primitive. Yeah. Let's see what we get here. This will be interesting. Okay, primitive name, unsigned int. Yeah. Yeah, unsigned int. Unsigned int, yeah. How about we put an assert here? Assert starts with unsigned. If we get if we hit this assert, then I think it means that we are missing. Wait, name. Not starts with unsigned. Not starts with signed. So if we would hit this here, and we can also say not ends with a long int and short int. Short int, long, short, unsigned, short, blah, blah, blah. Yeah. Short int, right? Short int, yeah. Yeah. If we hit one of these asserts, then we need to check. That means we can probably remove this here. Yeah. It's primitive. Oh, I think we should put a space here. Space. Yeah. Because otherwise, if there was a class or some regular type ending on starting with unsigned, then this would hit. So we should put a space here. Yeah. Space. And this already has a space. Yeah, I think that's better. Let's try this again. Signed, unsigned. Mm-hmm. All right, so unsigned int, yep. Unsigned int. Okay, there we got a lot of these, yeah. Is number, int, int, okay, that looks good. I think we can skip on that. Let's see if we hit a assert. Oh, we do. Oh, unsigned char. Huh? Huh? Oh, it's here. Huh? Did I misspell it? Unsigned char. Hä? Why is this hitting? Am I retarded again? It's supposed to return here. It loops through all the names. It compares with all. Huh? Unsigned char. I don't get it. Why? How is this assert hitting? Unsigned char. Is there anything special about this? Unsigned char. No. There's nothing suspicious in here. I don't get it. If name equals unsigned char, int a equals 0, put a breakpoint in here. That can't be. How is this possible? What is this here? Jesus Christ. Man, this is... sometimes... I don't see the error. There must be an error, but I don't see it. How is this possible? Why am I blind? That's unbelievable. Oh, man. This is retarded. This is very, very... unsigned char. Okay, so it hits here. That's good. So primitive name. Could be that it doesn't like loop through that thing. So name equals char. No. Short. No. Int. No. Long. Long. Float. Oh. There are commas missing. Oh, that's so sneaky. Look at that. Oh my gosh. Yeah, there you go. There were commas missing here in this list. Oh my gosh. The noob mistakes. It's unbelievable. It's kind of funny that, yeah, it doesn't, the formatting doesn't show that. Oh boy. That's funny. Okay, let's remove this. Actually, let's step through and double check it. But it should work now. Long, floats, double, long double, unsigned char, true, boom. All right, let's remove this and start again. Let's go. Let's go. Long int, short int. Yeah. Okay. That has run through without any errors. Let's see what we got. Classes. Oh, a lot more classes now. Look at that. And a lot more enums. 61. Let's look at that. Let's look at that. Oh, vector 2, vector 4, vector 3. These are not... these are classes. Enum sound list is probably also a class. This is probably also a class. This one looks like an enum. Class, 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 class. Class, 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 class. Well, class, enum, class, class, enum, enum, class, class, enum, class, 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 class. There's a lot of classes in here. Yeah. Oh, we have a bool in here. Oh, I forgot that. Look at that. Relationship is enum, 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 class, enum, class. No, enum, invalid, class, 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 class. I say, okay, to me it looks like the most of these added here on enums, they look to be classes, to be honest. So maybe we should all classify it as classes. And then we say it's maybe an enum. Yeah. 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 Okay, well, what do we get on classes? This is also much larger. Let's see. Oof. Okay, struct, yeah. Struct class. Yeah. Struct, class, struct, class, class, struct. Struct. Okay, we get a lot of these STD classes. Holy shit! These will all be type defs. But I think we don't create type defs. We just drop in as is. But we don't care about allocator actually. Yeah. See allocator. Okay, one thing I would like to do is to do add a struct type, because we can actually distinguish between class and struct just by this name difference. So we can have some structs. Add a struct, yeah. And the other thing is, I think we also should no, I think that's already covered. So if we go from here, from arguments, find or create enum by name. Enum by name. Enum by name. Class. Here on the enum creation, we don't look for parents. I just realized. Yeah. We don't look for parents. Let's add a to do here. To do generates parents too. Yeah. And this one already takes care of the parents. Here we can remove this. And then parent is class or namespace. I think this will be the same for enum, this thing here. Yeah. Likely. Find or create class by name. Find or create class by name. Actually, we don't need this, but what you can say is in the class is template class. Let's say bool m is struct false. This is a struct. When we say here m classes class index dot m is struct equals false to do implement. Yeah, we don't have a single function yet for struct, so we need to do that. Okay, let's do that next session. I think this one we can conclude. Maybe we can make a few more minutes. Maybe we can at least finish that. How about that? So we have is typical class name. Let's see. How about we do the following? Static bool is typical X name std string view. Hold on. Std, let's say char prefix std string view suffix. I don't know why Visual Studio shows this huge list there, but that is outrageous. Okay. Let's go here. Let's implement this here, there. Okay, and then here we copy this here, and then we say ends with suffix prefix. Let's call this prefix char suffix string. Let's make it 3 characters. Prefix chr, str. There we go. Okay. Let's remove this. std. All right, let's remove this. Okay, and then is typical namespace return is typical X name enum. There we go. Name is incorrectly spelled. Okay, e blah blah. Okay, and then is typical class name C and class. Oops, class, and then we need another one. Is typical struct name. make a copy of this, this structs my class, my type, as my type, my struct are considered structs. Yeah, is typical struct name. We take this guy and we put it down here, and somehow we can't make a copy of it. Why not? Copy, please. Thank you. MachOCodeGen and we copy this guy and put it here. So this is S and struct, and then we can remove all this, and look at that, beautiful. It all goes through this one here. Yeah. I think that is good. All right. So now we can say is typical class name or is typical struct name, class name, then it is a class, yeah. And so get candidate type. Get candidate type is find or create class by name. Yeah, so basically here in the class, no, where's it going? Find or create class here. And now here it should say is typical struct name. Class name. Okay, that should work. Let me put a breakpoint here. Condition struct equals true. Let's see if it holds true. Is struct. It's typical struct name. Let's see. Yeah. Font chars class char data struct. What the fuck is this name? Font chars class char data struct. Ah, font chars class char data struct. Yeah, makes a lot of sense. Yeah. Sorting node struct, pick drawable struct, call node struct. S list. Ah, yeah, that looks like a struct. S list. Yeah. S list. Yeah. Wait info struct. I really appreciate that they have a lot of struct and class names in there. That helps a bit. No? That's nice. That's nice. Yeah, okay, that looks good. Looks good. Okay, cool. But yeah, I think what we should also do, and afterwards we really take a break here. Well, not that anyone is actually watching and listening. I wonder if anyone is actually listening to what I'm saying right now. The last videos didn't get much hits here, which is understandable. Like, why would you sit through this and watch this? It makes no sense. I do wonder if someone is listening right now. It's probably very unlikely, sitting through 2 hours of this, I mean, I wouldn't watch it. I wouldn't watch it. But I guess someone who maybe wants to learn C++ or just like tune in a bit, that makes sense to just see like, okay, let me get the gist of it. Let's watch 2 minutes and, you know. But yeah, it's very unlikely to follow this closely. Anyway, what did I want to do? Now I forgot. I talked in rage, and I forgot what I wanted to do. We wanted to. Right. By the way, we can delete this one here. We wanted to clean up a little bit. Yeah. Wow, this one is expensive. Here, this one. So I think we should create classes first and enums last. Put this here, put that here, there, and else if. Yeah. 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 Simply because it looks like there are more classes in the list. Yeah. More classes. All right, let's say this. Okay, so now we have still just 3 enums, but we have a lot more classes. And this one will also contain obviously some enums, but that's fine. Yeah, let's see. So vector 3 is now a class. Well, it should be a struct really, but we don't know. Yeah. Vertex class, polygon class, quaternion. So all classes, yeah. Okay, now we got a lot here. Also got a lot of std vector classes. A lot of std thingies. Yeah. I think these are all from arguments and so on. Yeah. Yeah. Yeah, but that's fine. We can ignore these in the end then. Yeah. Yeah, I think everything that is in std namespace we should ignore. ATS hash. Yeah. Okay, this looks very promising. Yeah. Good. Maybe one more note. Let's go in here. Yeah. To do build links question mark. Yeah. Let's think about it next session. I don't wanna. I wanna take a break now. This is enough. Okay. Good. So that was almost 2-hour session. I think we're done here. And yeah, I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.